All right, guys, we started proportion or prop theorem 2 days ago on Tuesday. So here, remember what that theorem says is that you have a line dividing, or sorry, a line that is parallel to a side of the triangle. Then that line divides the other two sides in the same proportion. So in this case, that line that divides or that is parallel to the one side there is ST. All right, so that theorem, prop theorem says, thank you, that ST divides those two sides in the same proportion. So remember I told you, look for what you are trying to solve. We're trying to solve for x here. So that goes at the top of your first fraction. Okay, that just makes the whole process easier. So you're going to say x over 10. But this is now bottom over top, right? That must then be equal to bottom over top on the other side of the triangle. Alright, so x over 10 is 2 over 5. You then multiply by 10 and then you get your answer. Please remember you have to write prop theorem and ST parallel QR. Yeah? It's fine, but then your calculation is more difficult. So then if you have this, then you first have to times by x on the other side. And then divide 10 by 5 over 2, which is fine. It will work. It's just more difficult. Right, any questions on that one? Okay, number 2, we had to find y, which was this top side here. But now, guys, they didn't give us the bottom one. So I can't say y over bc because I don't have bc. All right, we have to take y over the whole side, 35. And that is then going to be equal to 18 over the whole side. All right, so in this case, the whole side here is going to be 18 plus 24, which is 42 centimeters. All right, remember you have to match up the two fractions. It has to be the same sections of that triangle. So y over the whole side is 18 over the whole side. And why can I do that? Because BD is parallel to AE. So you have to write prop theorem and then state which sides are parallel. Right, once you have this, all you're going to type into the calculator is 18 over 42 times 35. And then it will give you your answer of 15 centimeters. All right, number 3. We have that. Now this one was a bit more difficult because we had m's on both sides, right? Yeah.
And so with the prop theorem, you can calculate any side.
Yeah, as long as you have... So it's not that you can calculate any side. We usually use it to calculate sections of sides or parts of sides. So here we can calculate this when the whole triangle is actually this.
But in that triangle, could you calculate EF as
Thank
well?
you. EF. No, we couldn't. No, so prop theorem doesn't work with the sides that are parallel. Okay, so if we see that we have a side that is parallel to a side of the triangle, then this line divides the other two sides. Okay, so unfortunately we can't use it to find EF. Okay, guys, so now even though we have to solve for m, it's okay. We're still going to set up our equation. The equation is just a little bit more difficult to solve. Okay, so we're going to say, and here you could have put either side first, it doesn't matter. I said m over 2 is m plus 2 over 3. Right? Top over bottom equals top over bottom. Okay? Prop theorem, GH parallel to EF. Then what I did, you could have done this in 2 steps. So I left my m on this side, and then I would have had my 2 times m plus 2 over 3. Right? You see, to move that 2 over to the other side, you have to multiply by 2. Right? Because on the left, I'm dividing by 2. But then now what must I do with this 3? If I move that 3 to the other side, I'm going to multiply. Right? What am I doing here? Dividing by 3. So on the other side, I have to multiply. So that is where 3m equals 2 times that whole numerator. That's where that comes from. Okay, I just did it here in 1 step, but you could have done it in 2. And then from there, I multiplied my brackets out. So I had 3m is equal to 2m plus 4, and then I just moved the 2m over to the other side. All right. Number 4 is one that I kind of helped you with on the board, but you still had to do the calculations for that. So remember, guys, here we have two triangles that are connected, right? So we have in this bottom triangle that GD is parallel to that side of the triangle. So that means that in the bottom triangle, GD divides those two sides in the same proportion, right? So I said FG over GC is 22 over 33. Top over bottom equals top over bottom, right? But then in the other triangle, we also have a line going from G. That line is now GB, and that line is now parallel to that bottom, well, that top side. So now we say that this line divides the other two sides in the same proportion. So now we can say top over bottom is equal to top over bottom. Right, so we have those two. Please make sure that you are writing the correct sides here. You have to say EF parallel to DG for this one because we're looking at this triangle. And for the bottom one, you have to say AF parallel to BG because we're looking at that triangle. Now, guys, like I put on the board the other day, these two fractions, right, are both equal to the same thing, FG over GC, which means that these two have to be equal to each other, right? The top fraction is equal to FG over GC and the bottom one. So if they're both equal to the same thing, that means that they must be equal to each other. So from there, you had to put them equal to each other and then solve for x. Okay. Now, you didn't have to do number 7, but I would like you quickly to copy number 7 down into your books. I just want to do this one with you. Number 7 is very similar to the one that we just did in number 4. It has this exact same picture, but in number 7, yeah, the letters are slightly different, and also they didn't give us any values. The question for number 7 is prove that AD to DB is equal to GF to FB. That is the question for number 7. So please copy that picture down and then just write the question down, and then we're going to do that one together. Okay, now guys, this one is more difficult than the previous one because in the previous one we had numbers to work with, right? In this one we don't have any numbers to work with, and also this is unfamiliar, this way of writing the ratio. Now, I think I did mention this on the board the other day, but a ratio like this can also be written in fraction form, right? So AD to DB is the same as AD over DB. Right, that means the same thing. Both of those are ways of representing a ratio. And then on the other side, GF to FB is the same as GF over FB. Right, it means the same thing. So I think it's probably easier for us to work with the fractions because then we can use prop theorem. All right? And then in our final answer, we can just convert it back to ratio form so that it's written like that. So guys, essentially this is what they want us to prove. They want us to prove that AD over DB, now let's see, that is AD there at the bottom, right? This is AD and that is DB. They want us to prove that fraction is equal to this fraction. Now, we can use prop theorem, but remember, if we want to use prop theorem, then we need to work in one triangle at a time. Okay, and what we have here is, again, two triangles, thank you, that are connected with CB or CEB. All right, so guys, what we're going to do is we're going to say AD to DB, or AD over DB, is equal to what? CE over EB. Because of prop theorem, because this line DE is parallel to AC. All right, so that's going to be our first line. We're going to say AD over DB, right, is equal to CE over EB. And the reason for that is prop theorem. And now because we're working in this bottom triangle, we have to say DE parallel to AC. All right, so we have the first half of that statement that we need to prove, right? We have that first fraction. Now we need to bring the second fraction into the mix, so we have GF over FB. Now what is GF over FB going to be equal to if we're looking at this top triangle? CE over EB again, which is the same thing, right? So now we're going to say GF over FB is equal to CE over EB. Again, this is because of prop theorem. But now we're working in the top triangle, so now we have to say EF parallel to CG. Now, like in the previous question, we can see that both of these fractions are equal to the same thing, which means that they must be equal to each other. Good. So now I'm going to say, therefore, AD over DB is equal to GF over FB. You don't need a reason for that. That is just coming from our previous statements. But now, guys, remember they told us that we must prove this. Okay, so even though it means the same thing, we have to, in our final line, just go back to writing it in the form that they wanted us to prove. Whenever it's a prove that question, your last line must always be what they've asked you to prove. Okay, so please just rewrite it then in ratio form. Yeah, does that make sense?